Hi, my name is Yair, and today I would like to talk about a mystery topic. But this mystery could be different than the usual because it's about a math problem. In specific, the Riemann hypothesis that talk about the mystery of the prime number distribution. So let's start. For begin, what would you do with $1 million? Probably, I think that I buy a house, maybe travel to another country, or spend all my day playing video games without without going to work. I don't know. Maybe a relaxed life. Well, the Climate Mathematics Institute is offering just that for solving one of the most profound mysteries in all of mathematics. Today, we are going to explore this problem, the Riemann hypothesis. So, what is it? Well, the Riemann hypothesis was proposed in 1859 by Bernhard Riemann. Bernhard Riemann is this person that you can see. And in that moment, Riemann must have known he was touching upon something fundamental. He could have stumbled it by accident, but it's more likely he understood its deep significance from the start. To understand better the Riemann hypothesis, we need to see what is a prime number. Maybe you has already seen this concept uh, before, maybe in the secondary. And as you know, a prime number is a number that has to be greater than one and divisible one only by one and themselves. So in the square, we can see some prime numbers that we have, like the 2, the 3, the 4, the 7, the 11, 13, etc. Knowing this, we can pass to the next part, that is the zeta function. As his name says, the zeta function is a function, but how we can discover this function? In the past, important mathematical uh, create a graphic with approximately 3 million prime numbers, and with this we can find like a curve and like a function, but we in that moment we couldn't know what was the exact function. So in so some years later, a person found that a specific function was related with the graphic of the prime number. That was the harmonic function, but this function was different. The the change that the mathematical people have to do was replace the power of the positive integer of that series to the same number. With this, we could have a function so similar to the graphic that was created in the past, and this word was called, and this function was called that's like the zeta function. A representation of this is like the graph that we could have in the left part of the presentation. This is a comparison using the zeta function with the original graphic of the prime numbers. The most important part of the hypothesis involves the zeros of the zeta function. A zero is a simple number s that you can plug into the function to make the result equals to zero. And we have two types of zero. The first are the trivial zeros that are simple, occurs with the negative numbers, even integers like -2, -4, -6. But there are other and more mysterious that is called non-trivial zeros. Riemann calculate the first few of these and notice something started. They all seem to tie on a specific line in the complex plane, known as a critical line, where the real part of the number is 0.5 or 1 half. The Riemann hypothesis is a statement that all non-trivial zeros lie on this single straight line. Mathematicians would have been shocked by this perfect order emerging from such a complex function. It's like finding all the chaotic waves in an ocean are peaking at precisely the same latitude. So, what if it falls? To answer this, I decide to divide the answer in three parts. The first is that we we could have a chaos ring. The prime numbers will be for more random and more chaotic than we currently believe. The elegant formulas that we have for estimating the number of primes will have to be modified as they rely on the hypothesis being true. The second part is that the cryptography may be affected. As you know, we currently live in a world with technology. We use applications in our day and save information about us. To protect this information, we use cryptography. Cryptography uses algorithms to ensure our information. These algorithms take part of prime number theory and Riemann hypothesis, and a false hypothesis could have implications for the security of these algorithms. Though this link is not direct, it may provide insights that lead to new, faster factoring methods, potentially breaking modern encryption. And the third part is that a century of proof will crumble. Hundreds, if not thousands, of mathematical proofs have been published that begin with the words, assuming the Riemann hypothesis is true. If it falls, all of that work of those mathematical structures built on this foundation would have been built on sand, they will all be invalid. As a conclusion, a false Riemann hypothesis would mean that the universe of numbers is messier and less elegant than we hope. It would be fascinating but terrifying discovery, and that is the mystery that awaits its millions dollar solution. Thank you for your attention.